So when were you going to start?
Whenever we're ready.
Oh, okay. Well, I guess is this recording? I would wait for him to come back.
Okay.
Yeah, I'll go let him know. But
Okay. All right, shall we get started?
Yes.
All right. Thanks. Sorry to keep everyone waiting. Thanks for coming. My name is Jason Brooks. I'm an engineer with Google on the Politics and Elections team, which is part of the broader Civics and Humanity organization in Google.org, our philanthropic arm, where we work on projects to organize the world's civic information and try to drive.
Can you speak up a little bit?
Yes.
The mic.
Is it better?
Yes.
Great. And projects that aim to drive social impact. Just for a point of clarity, I'm not actually on the Dart team. I've done a lot of work with the Dart team, and I've released a couple of production apps in Dart, and I'm here at their request to sort of share some of my experiences and let you know what I think about building with Dart. Just for a little bit of background, I came to Google about 2.5 years ago, and I've worked on a variety of front-end systems using a variety of different technologies. And one of the things that always struck me about web development in particular is that it's, particularly coming from a Java background, which I had before coming to Google, is how unstructured and kind of Wild West the web world is. Working with systems for the web is always sort of an exercise in trying to bring order to what's not naturally an ordered environment. About 1.5 years ago, I heard about Dart and started playing around with it and got excited about it mainly because it tries to bring some structure back to this environment. And now that I've actually been through the exercise of building some real apps in Dart, I'm convinced that Dart not only makes for a better environment for programming web apps, but can actually improve the design of your whole front-end system. And so that's what this talk will be focused on, is building better front-ends with Dart. Just by way of caution, this presentation was assembled in a factory that handles code. And code will be strewn throughout, so if there's any allergies in the room to code, or anyone's uncomfortable looking at code, there's plenty of coffee outside. Otherwise, let's get started. So what do I mean by better front ends? This is potentially a controversial topic, but I'd like to define, in this case, a better front end, not necessarily from the perspective of the user. Obviously, a web application has to be responsive and usable. Nobody's going to argue that, and that's got very little to do with the technology. But I would argue that a better front end is something that's easy for the developer to write. I should be able to make progress. I should be able to have productivity and be able to move quickly without working against the system that I'm developing in. It should be easy to deploy. I should be able to make frequent updates to my app. I should be able to get them out there without too much effort, because this gives me the freedom to innovate quickly and move quickly and be responsive. It should also be easy to maintain. So the code needs to be clean, it needs to be modular. I need to be able to get in there and find bugs. I need to be able to fix them and have the confidence that fixing one bug is not going to break a bunch of working parts of the system. And it should be easy to evolve. So I should have the tools that I need to get in there, remove old code, refactor code, update my dependencies, and get to the point where I can add new things to my system, again, with the confidence that I'm not going to break the parts that already work. And so this leads me to also the need for a clear division of labor between the parts of my front-end system. Obviously, any front-end is going to consist of some kind of service that I connect to that provides me data, and an app that actually runs in the browser. And so I think it needs to be really clear in your front-end design what's the distinction, what goes where. And the promise of web apps was always that we could put all the good stuff in the browser, right? All of the important work should actually happen in the client itself. But traditionally, this has actually been really hard. Let's look at the tools we've had to work with to see how this is possible. If we just look at programming in raw JavaScript, JavaScript is a great language. It's very expressive. You can do a lot of interesting things with it. And it's great for prototyping. But it doesn't have a lot of the tools that we actually need to build an entire web application. For starters, I need to generate chunks of DOM, so I need some kind of templating library. I'm also probably going to import dependencies. Probably I didn't write all the code myself, so I'm going to reuse code from somewhere else. And JavaScript doesn't have built-in dependency management. I've got to figure out an answer for that. And I also have to find a way to edit my code. There aren't great editors out there for JavaScript. There's a few that try to solve this problem. But because JavaScript doesn't have a very solid structure of its own, it's actually really difficult to build tools for it. And then eventually I need to find a compiler that's going to be able to minify and obfuscate my JavaScript code, make sure that it runs fast. And then once I've built a substantially large app, refactoring that app can be really difficult. And this goes back to that evolution step that I talked about a minute ago. And again, this is because I just don't have great tools for accomplishing this task. So how about Google Web Toolkit? Has anyone here ever programmed a Google Web Toolkit? So these were some of the problems that Google Web Toolkit, or GWT as we like to call it, attempted to solve. Right? For starters, the whole idea behind GWT is that I can write Java code, and I have a system that translates the Java code into JavaScript. And the whole idea behind this was Java already had all these great tools. And so if we could just use Java for web development, we would get to take advantage of all these great tools. It also gives me the promise that I can share code between the client and the server, which is really quite compelling if I have a lot of application logic that already lives on the server side. I get to reuse Java code that I already have. So this is potentially a huge productivity boost. But again, once my app starts to get large, I start to run into some of the limits of this system. Namely that I'm stuck at the intersection between these two languages, Java and JavaScript. I don't have all of Java, because I only have the parts that can be safely compiled to JavaScript. And I don't have all of JavaScript. I don't have things like first-class closures, and I don't have things like dynamic typing. So we start to run into some limits. And then similarly, once the app gets large enough, the whole compile, refresh, reload cycle becomes really long. At Google, it's not uncommon for us to have large applications that may have tens of thousands, hundreds of thousands, millions of lines of code. We might have dozens or hundreds of engineers working on them. And you can have apps that might take 30 seconds to rebuild and refresh, which is really killer for productivity. So GWT works, and we've used it successfully for a lot of things, but it always feels like we're working around the fact that we're developing for the web, rather than actually developing for the web. Now everybody's probably thinking about JavaScript frameworks. There's tons of them out there. Why don't I just use one of these JavaScript frameworks? Well, the great thing about JavaScript frameworks is there's so many of them, right? And they all do about 50 to 60% of what I want. So generally using JavaScript frameworks is an exercise in assembling a whole bunch of frameworks together into a large app. And now I'm right back to the problem I had before, which is how am I going to manage the dependencies between these things, and what happens when one of the libraries needs to be upgraded but doesn't quite match with one of the other libraries that's not ready to be upgraded. And similarly, I'm going to end up downloading a lot of code into the client, into the browser, just to get a few of the capabilities from each of these frameworks. So we think we can do better, and this is where Dart comes in. So Dart is, I'm going to define it as a structured development platform for the web. A lot of people came here probably thinking Dart is a language, and this is true. But I think Dart is a little bit more than that as well. We like to call Dart the batteries included platform. And this is because it is in fact a language, but it also comes with a whole bunch of great libraries that are ready for working on the web. It also comes with first-class tools. There's an editor you can download for free from dartlang.org. It's built on the Eclipse platform, so it looks and works like Eclipse, but it's not built on Eclipse, so it doesn't take 10 minutes to start up. And but you do get all the great tools like refactoring and code completion, built specifically for Dart. And you've also got the first-class debugger, where we can attach to live running code and actually inspect the code. There's also a virtual machine for Dart. And this is great for the development refresh cycle, where we can actually launch code from the editor to run in a special build of Chrome called Dartium that includes the Dart VM, which can run Dart code natively without having to compile it to anything. And this gives me a super fast instant refresh cycle where I don't even have to wait for a compile step. But ultimately, I want to be able to deploy my code not just to this special build of Chromium, but to any modern browser that runs JavaScript. And so there's a Dart to JS compiler, which is a ground-up compiler written in Dart that takes your Dart code and compiles it to JavaScript that'll run in any modern browser. And it takes care of a lot of things for you, like minification, but it also does tree shaking, which means it figures out which parts of your app are never going to get used, and it pulls them out for you, so the app size is small. And it can also do things like optimize your code. So even if your Dart code isn't written totally optimally, the JavaScript it generates can be more optimal. So that's the batteries included platform. So I want to take a closer look, though, now first at the language, and talk about, again, why I think it makes for a better front end. First of all, we get a very expressive syntax. Right out of the gate, you notice we have classes. This is something that's new from JavaScript. But I call class hug with a curly brace syntax. It's starting to look pretty familiar from any kind of C or Java-based language. I can declare a member property, and then I also have a constructor called hug that takes an argument called strength. What's actually happening here? Well, every initializer in every language, when you pass arguments to the constructor, the first thing they do is save off a copy of the value, right? So normally I'd have to do this.x equals x, this.y equals y. Dart makes this a lot simpler by simply doing this.strength in the constructor, and it knows that because that matches the name of the member variable, it can do the assignment for me. So it's terse syntax. We also have named constructors. So it gives me a natural way that I can type new hug.bear, and I know I'm going to get a really strong hug back. We've got operator overriding. So this is something that's new to Java and JavaScript developers. This exists in plenty of scripting languages, but this lets you define natural behaviors for your classes. We've got optional arguments. Again, this is something that we're familiar with in JavaScript, but in this case, we've got optional named arguments, which means we don't have to just do a big long list of arguments and remember the order that they show up positionally. We can just name them. So in this case, it's hands : and I can also provide a default value. So in the implementation of my method, I don't have to go check and see if that value has been defined. I can provide a default value, and my code can just assume there's a value set. We've got shorthand expressions with the fat arrow, which basically say if I've got a method that has a quick return value of a single expression, I can just return it. And we've got string interpolation. So again, I don't have to worry about long string concatenation or funny syntax. I can just put values right into my strings. So we're really focused here on having a very terse, short, easy-to-use syntax. Another example, everyone's seen something like this if you're working with the DOM. In this case, I'm just initializing a button, setting a bunch of properties on that button, and then I've got to add the button to the parent container. So in this case, I'm writing the word button 6 times. Dart says, we can do a little bit better than this. So Dart has a cascade operator. And this will be familiar to anyone who's used jQuery. jQuery libraries are designed so that they always return the object that you're operating on, so you can chain a bunch of calls together. But this has a side effect. That means if you want that behavior in your app, in your classes too, then every method you write has to return the object you're operating on. That doesn't always make sense for your API. So Dart says, well, we can just do this for any object. With this cascade operator, the ... whatever the last object is I referenced on the line, I can then just call a property or method on it. So again, this gives me the chance to be a little bit more succinct and more readable in my syntax without having to mess with my API. And it even gives me the chance that I can go for fully inline initialization where I can do all these steps on an object without ever even having to give it a name. So that's syntax, but I don't want to give anyone the impression that Dart is just syntactic sugar on top of JavaScript. Dart actually has its own semantics, and I would argue that these semantics are pretty clean. If you're coming from the JavaScript world, you're familiar with the concept of truthiness and falsiness. This is something in JavaScript or Python that can be quite useful, but it's also the source of a lot of subtle bugs if you have values that you weren't necessarily expecting. In Dart, only true is true. And there's no undefined, there's only null, which means every value when it gets declared has an implicit, every variable when it gets declared has an implicit value. It's either the value you assign it to or it's null. And you can check for null, but you're never going to have an undefined value. And then similarly, we don't have to do type coercion like JavaScript does when you're using the equals equals operator or the concatenation operator. Your types are the types you expect. All right, so Dart also has lexical scoping. This is something that is not necessarily the case in JavaScript, but this is also the source of a lot of confusion for people that are new to JavaScript. I got a pretty simple program here. I declare a variable called x and assign it to 1. And then I've got a function that checks to see if x is defined. And if it's not, it defines it to 100. And then at the end here, I'm just going to pop up an alert box with the value of x. So what happens when I run this? Does anyone know? We're hoping we're going to get 1, right? We actually get 100. So why is this? This is weird. This is a weird idiosyncrasy of JavaScript. JavaScript's scoping says that all variables are scoped at the function level, not necessarily in blocks. And it has a feature called hoisting, which says all variable declarations actually get hoisted to the top of the scope. That means that var x equals 100 is actually hoisted for me right up to the initial function definition. So even though my code doesn't execute because x is defined, x gets redefined in the scope. So This is confusing, and it's potentially powerful if you know how to use it, but it's also the source of a lot of subtle bugs in JavaScript. In Dart, I can write the exact same program in the exact same order, and in this case, I'm going to get the one that I expected. All right, looking a little bit further into the semantics, Dart has libraries. Libraries are effectively namespaces where you can define your functions, classes, and values. Libraries can be made up of any number of these things, but whatever's in a library is in a library. This is something that's new from JavaScript that doesn't have native namespacing. Dart also has a single entry point for every program. It's got a main method. This is familiar too if you've done C or Java. But this is something that's new from JavaScript. In JavaScript, the browser actually interprets your code. It starts running your code as it downloads, which means you've got to be really careful about the order in which your code is downloaded, because it's going to execute in the order in which it appears. Well, in Dart, the whole program is downloaded first, parsed and understood by the browser, and then executed starting from your main point. And so this gives you things that you'd expect from other languages, like forward declaration. I can refer to new tornado even though I haven't declared the tornado class yet. Similarly, I can do real compile time constants. These are objects that exist at compile time, and I can use throughout my program. I also get library level visibility. This is something that JavaScript doesn't really have except through name obfuscation. In Dart, any variable name with a leading underscore is private to the library. So this is really useful for encapsulation. We also have a feature called properties. And properties are the notion that I can use the dot syntax, in this case twisty.force less than 2. I'm actually just getting the value of twisty.force, but the implementation down below is doing something else. And so this is familiar to anyone who's come from Objective-C or some other language that have properties. But this gives me a way that I can provide an implementation for the value of the property that's different than the actual variable declaration. And so I have the same thing with setters. I can do twisty.force equals 2, even though under the hood, Dart's actually invoking a method that I define that multiplies that value. All right, so those are some of the elements of Dart semantics. I want to talk a little bit about how classes work in Dart, because this is also something that we don't really have true classes in JavaScript. For starters, I get abstract classes, and I have real instance variables on my classes. So in this case, I can declare behavior that I haven't defined yet, and I know that everything that derives from cat is going to have a name. Inheritance in Dart is single inheritance. We can only have one parent at a time. This is like Java, and this prevents potential bugs that you would get from multiple inheritance. And now I've got again, like I said, real instance vars, which I can implement as properties or as attributes. And we talked a little bit already about constructor initializers and named constructors. There's one more feature that's interesting in Dart called factory constructors. Now I use these exactly like I would use any other constructor. I can do new lion with a name. But what my class is doing under the hood here is not actually necessarily or instantiating a new lion every time. In this case, I'm actually checking my cache to see if there's already a lion by that name and returning it. And if not, I can create a new one using some private constructor. What's really nice about factory constructors is you don't have to build them in from the beginning. I could have designed Lion to create a new one every time and later on added caching without having to change my API. And that means I can change the implementation without actually affecting the callers of this method. All right, so one more example here. Sometime later, somebody goes and adds a class called roar. I really want to use this class because every lion needs a roar, and mine doesn't have one. But how do I get this roar implementation into my lion? Well, in Java, I wouldn't really have much of a choice but to derive lion from roar. I'd have to stick that roar class into my inheritance hierarchy. But that doesn't really make sense, right? Is it fair to say a lion is a roar? Not really. But I still want the roar in my lion class. So in Dart, we handle that with mix-ins. If we have simple implementations, my lion can still extend from cat, which makes more sense. And I can say with roar, and that basically imports the roar behavior right into my lion. So I can compose my class of a whole bunch of different behaviors from different places without polluting my inheritance hierarchy. And this makes for some really clean class design. So that's classes. I also want to talk about optional types. This is something that's gotten a lot of attention, but a lot of people don't necessarily know exactly what this means or how this works. So I want to walk through what this looks like. Here I've defined a simple class, point, contains an x and y, and I've got an addition operator that lets me add 2 points together. So if I've got a 0.23 and a 0.32, I add them together, I get 0.55. So there's nothing surprising going on here, except that the word point shows up a ton of times in this program. Obviously, I need the first one because I need to declare my class as point. But do I really need all these other points? Well, Dart lets me write code like this. In this case, I've removed the word point from everywhere I don't actually need it. When I create a new point, obviously I have to say new point. Everywhere else, I don't actually have to name these fields. So my x and y are no longer typed as num, and the operator no longer has to operate on a point. And I've got variable declarations below, just like JavaScript. And what happens when I run this program? Well, I get the exact same thing. And this is because the use of the word point everywhere that it shows up as a type annotation is just that. It's just a static type annotation. It's just a hint to the program that I'm expecting a point in this case, but it doesn't affect the runtime semantics of this program. So to illustrate this a little bit further, I'm going to do something really screwy. In this case, in my class definition, I've said that x and y are now string. My plus operator takes a num and returns a bool, which kind of makes no sense because it's actually returning a point. And I'm going to create my 2 points, 2, 3, and 3, 2, but assign them to button and stream, and then I'm going to try to add them together. So this is kind of wacky, right? So what actually happens if I try to run this? Well, if I try to compile it, I'm just going to get a whole bunch of warnings, right? The compiler is going to look at this and say, this makes no sense. I can tell that you're returning a point, you say it's a bool. I can tell that you're trying to call .x on something that's supposed to be a number and doesn't have an x property. So the compiler is going to tell me there's a problem. But what happens if I actually run it? I still get 0.55. And again, this is because all of these annotations are just that. They're just annotations. They give me what the tools I need to tell my compiler and to tell the reader what I'm expecting about my program, but they don't actually affect the runtime semantics of my program. So I'm not suggesting that you should go out and make your program as confusing as possible by using all the wrong annotations. I just want to illustrate that this is an important feature because it means you can use annotations when they're useful, and when they're not useful, you can get them out of the way. So this makes for some really clean API design. All right, that's optional types. Now, that's kind of it for the language tour, but Dart also comes with a bunch of libraries. And there's a lot of useful libraries in there, but I only want to talk about a couple that I think are really important. First is the async library. Now, anyone who's programmed in JavaScript knows the browser basically gives us a single main thread to do work. And that means that for any long-running calls, we basically have to deal with callbacks. So in this case, this is a real service, by the way. Obviously, at Google, we only deal with cat videos. So I've got my cat service here, and I need to make a couple of calls to my cat service in order to get some data back. Eventually, I want to actually just be able to perform some image manipulation and draw an image. But because my cat service is some long-running service, it has to deal with callbacks. So I get the cat data and pass in a callback, and then that takes the result and passes in another callback so that eventually I can get a response and do some work. So this is 4 levels deep, just because I need to hit 3 services. So this gets really confusing, and if I was doing anything more than just draw, this would be really hard to debug. But what if I also want to do error handling? What if cat service can throw an error because it's busy? Well, then I need something like this, right? Every single callback also requires another callback, which is the error callback. And this gets really ugly. Well, Dart has first-class futures. If you're familiar with futures in Java, or if you've heard about promises in HTML5, a future is the notion that you can do some chunk of work, and at some point in the future, you will get a result back. And when you get that result, you can then take an action. And so in this case, I can chain these futures together by saying, well, first get the cat, and when I get that result, then make this function call. And that function call also returns a future. So now I can make this nice chain. And finally, I do one catch error at the end. I could actually attach an error handler to every future call, but I can also just attach a single one at the end. And if an error occurs anywhere in this chain, it'll get handled by that one handler. So this makes for a much cleaner set of code. All right, but what if I want to actually make a couple of long-running calls at once, so I don't have to wait and do them all in sequence? Well, we have composition of futures using future.wait. So here I make 2 calls to the cat service, and I save off their results. Those results are both futures. I can do future.wait, which basically says I'm going to wait for both of these futures to complete, and then I'm going to do some work with both of the results. So in this case, I wait for both grumpy and happy, and when they both come back, then I can morph them together and do my drawing. And again, I can attach a single error handler at the end that's going to handle an error that happens anywhere in this future chain. So this makes for, again, really clean code, easy to debug. So futures basically are a way of getting a single event that I asked for sometime in the future. What about things that can generate events any number of times? Well, in Dart we have streams. And streams are basically a series of asynchronous events. So think about anything that can potentially generate events over the life of your program. This could be reading bytes from a file, getting messages from a WebSocket. These could be user clicks from a button, or they could be events coming from the DOM. Streams give me a simple interface that I can basically attach a listener to anything that's going to generate asynchronous events and then take some action. So in this case, I define my message service, and anytime it gets a message, I just call listen and give it a callback it can use with the message that it got. But I can do a little bit more with streams as well. Let's say I want to do something a little bit more complex and actually transform the results that I get. So here I'm querying for a text area, and I'm going to listen for key presses. But instead of just taking an action on the first key press I get, I'm actually only interested in certain key presses. I only want key presses where the key code is between a certain range. So I have this where method that basically transforms my stream and returns a new stream. And let's say, well, what I actually want is not the key codes themselves, but I want the strings from that key code. So now I can transform this stream into yet another stream using .map. And finally, I'm actually only interested in the very first one that matches. So I'll call .first, and that gives me a future. And now, like we talked about before, I can attach behavior to the future. And so now, the first time I get a valid key code back, I'm just passing that string to my message service. So this gives you a very powerful API for working with asynchronous events. All right. But we said earlier that Dart is meant to be a platform for the web. And so it would really be nowhere without a useful HTML library. Now, anyone who's tried to work with the DOM from straight JavaScript knows that it can be quite painful. DOM is not always well documented. It's not always clear what you're getting back. And it's not always clear what things are going to be supported in which browsers. And so basically every JavaScript framework you've ever used